Let C sub I equal the set containing I and negative I for each non-negative integer I. Part A, the union from I equals 0 to 4 of C sub I. Now, this union acts in a very similar way as sigma notation with summations. So here we have this index variable. For those of you who are in computer science, we can imagine a sort of for loop. But each iteration from I equals 0 to I equals 4, we're combining, which is the idea behind a union, the sets C sub 0, C sub 1, all the way up to C sub 4. So this is C sub 0, union C sub 1, union C sub 2, union C sub 3, union C sub 4. Now we can rewrite all of these C sub i's in list notation, or we list out all the elements. And keep in mind that C sub 0 is just the set containing 0 because 0 and negative 0 are actually the same element. They're both just 0. So union just means to combine. So we just have to combine all of these elements together into one set. And that is the result of part A. Part B is a very similar concept, but instead of all of these unions here, we're going to have intersections instead. Now, the intersection of all of these sets are just the elements that are in all of these sets, but there are no elements that are in all of these sets. And so that means the result here is just the empty set, the set containing nothing. Part C, are C sub 0, C sub 1, C sub 2 mutually disjoint? Explain. Now, mutually disjoint just means that the sets are completely separate from each other, which seems to be true. If you notice, when we go from C sub 0 to C sub 4, we list out all of these sets, and none of these sets have anything in common. The intersection is just the empty set. But when they say mutually disjoint, the difference there is that between any two sets here, there is no element in common. But we can say that these are all mutually disjoint because if we had some C sub I equals C sub j where I does not equal j, then that would mean that the set containing I comma negative I is the same set as the set containing j and negative j, which means that I equals j or I equals negative j. Now, I cannot equal j because by assumption, I doesn't equal j. But if I equals negative j, then we have two indices that are negatives of each other, even though C sub I is only defined for each non-negative integer I here. So there are no C sub negative any numbers. And so this is impossible too. So we can explain this using a proof by contradiction. The very assumption that two of these C sub i's are the same leads to a logical contradiction. And so therefore, all of these C sub i's are mutually disjoint. Part D is the union from I equals 0 to n. So this is going to be very similar to part A, except we're going to go all the way to n comma negative n. So we could say union dot 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 union n comma negative n. Now union means to combine. And so we have the set containing 0, 1, negative 1, 2, negative 2, and so on up to n negative n. Part E is the intersection of all of these sets. But as we saw with part B, that set is the empty set if we go out to I equals 4. Now, I will say that if n is equal to 0, then the intersection here would just be the set containing 0, which is not the same thing as the empty set. So there are two possible answers here. So we can say that the intersection here would be the set containing 0 if n equals 0, or the empty set if n is positive. Part F is the union from I equals 0 to infinity. Now we just have to imagine taking our answer from part D and we just keep going on forever. But if we were to keep going on forever, we would just get the set containing all of the integers. We would end up listing every single integer if we went on forever. So the answer to part F is the set containing the integers. Part G is the intersection from I equals 0 to infinity. Now this, we can just look at our answer from part E and imagine n is really, really, really large. We can take the limit as n approaches infinity. But no matter what, we're going to be under this circumstance where the result is the empty set. for all n greater than 0, which means that the limit would also be the empty set. Thanks everyone, and I'll see you in the next video.